So if you open that first flap that's labeled vocabulary, we have some words that we need to put formal definitions to. I know that most of these words in this flap look very similar to us, or we've seen them before, but now it's time to put an actual geometric definition to them, which you may have never heard before. So circles are something that are easy to identify, right? Like if we see a picture of a circle, we know exactly what it is. But the definition that we use is that it's the set of all points in a plane. Remember back to unit 1, way back, about a plane that are equidistant from a given point. So that makes sense, right? That leads to our next vocab word, from a given point. That given point is the center, the point around which a circle is described. So the center is the point, obviously, in the middle, and then when we get a certain distance from the center to another point and we keep making that same distance. So for example, if this was my center and I wanted to go 1 inch away, and then I went 1 inch away and 1 inch away and 1 inch away from that center, if we connected all of those points, you guys, that's how we form a circle. So this makes sense, or it should make sense based on these definitions. The radius, you guys know the radius, but the formal definition is a segment whose endpoints are the center and any other point on the circle. So this would be the radius. Okay, next is a chord. A chord is a segment whose endpoints, both endpoints, are on the circle. And we'll see what that looks like in a diagram in just a second. The diameter, again, we know the diameter, is the chord that contains the center of the circle. So it's a specific kind of chord, okay? Next is the secant. The secant is a line. That's good to know that the secant is a line that intersects a circle in 2 points. So remember, a line goes on forever and ever and ever, right? And a segment doesn't. A line segment stops at 2 endpoints. So we didn't say a line segment, we said a line. Next, tangent is also a line in the plane of the circle that intersects the circle in exactly 1 point. That's the difference between secant and tangent. So tangent is exactly 1 point touching the circle, and then secant passes through 2 points on the circle, okay? And then we have concentric circles. They are coplanar circles. Remember, that means they're on the same plane. So 2 circles that are on the same plane, or more than 2 circles, I should say, that have the same center. So if we go up to our picture here, let's fill in what we know from all the words that we've been given. So the first word we were given was the circle, and we don't really need to label that. These are all circles, right? And then the next word we were given was the center. So if you want to label that the center, that would be great. Then the radius. So this would be a good example of the radius. So let's label that the radius. And then the diameter is this two radii that are connected from here to here, right? So that's the diameter. Our next vocab word on our list was a chord. And remember, it said a segment whose endpoints are on the circle, but it didn't specify that it went through the center. So this would be a chord. The next, oh, I guess the next word was diameter, but let's move on to secant. Remember, secant intersects at 2 points, and it's a line, right? So 1, 2, it's intersecting the circle at 2 points. So this would be my secant line. Secant, and then tangent was touching the circle at exactly 1 point, which would be this guy over here. So this would be tangent. And then our last vocab word was concentric circles. So more than one circle. So there's 2 circles here, and they share the same center. So those 2 circles are concentric. And I accidentally put an E in there, concentric. All right, so make sure you fill in that picture. Okay, remember this whole green foldable is about circles and their properties of tangent lines, and we just defined what a tangent line was. That was a line that touches a circle at exactly 1 point, right? So here we come to our first theorem. So the theorem says in a plane, a line is tangent to a circle if the line is perpendicular to a radius of the circle at its endpoint on the circle. So here's the statement that we can make from this theorem. Line M is tangent to circle Q if and only if M, the line, is perpendicular to the line segment or the radius QP. And that would make sense, right? So my radius was Q to P, and the tangent line is line M, labeled right here, and those two things are perpendicular to each other because we established line M as a tangent. So that's a special property of every single tangent line. No matter where you draw the tangent line on the circle, even if it was touching right here, let's say, there was a tangent line, let's call this maybe line N, the radius connecting from Q to this point also forms a right angle or a perpendicular angle. So we know that that holds true for every single tangent line touching every single circle. Okay, so using that theorem that every tangent line touching a circle makes a perpendicular angle to the radius, we want to evaluate for the value of x, or find x. And they told us in all these examples, the line segment AB, or the tangent line segment, is tangent to the circle C. So we know that every single one of these angles are right angles. That's how we're going to use the theorem. Okay, so I'm going to do A and C, and then I want you to do for homework B and D, and then I'll check your notes. So I'll show you how to do A and C. So this looks a lot like a right triangle, right? So in order to solve for x, we're going to use the Pythagorean theorem, which everybody loves by now. So our C value is 100, so 100 squared is equal to 96 squared plus x squared. Well, 100 squared is 10,000. 96 squared is 9,216 plus x squared. So if I subtract 9,216 from both sides, that will give me, just a second here, 784. And in order to solve for x, we have to undo a squared, so we have to take the square root of both sides, and the square root of 784 is a clean number, so our value here is 28. So x is equal to 28. Okay, let's look at number C now. So they gave me the short leg, which was x, the long leg, which is 32, and then my hypotenuse from the center to point A is x plus 16. So how that's going to look is we have x squared plus 32 squared, because we have a squared plus b squared, is equal to the quantity x plus 16 squared. And remember, you guys, back from algebra, when we have a binomial or a algebraic expression with two terms and we're squaring that, this is the same thing as x plus 16 times x plus 16. So depending on how your algebra teachers taught you, you're either going to have to FOIL or what some math teachers call foiling, or double distribute. So you take x times x times 16, 16 times x, 16 times 16. So that's what we're going to have to do for this problem. So if we do the left-hand side first, we have x squared plus 32 squared is 1,024. So now let's double distribute this guy. So we have x times x, which is x squared. X times 16 is a plus 16x. 16 times x is 16x. And then 16 times 16 is 256. And I'm sorry that I'm running out of room, but just bear with me. Okay, and we can combine these like terms. So my right-hand side becomes x squared plus 32x plus 256. And then my left-hand side stays the same. X squared plus 1,024. So now I just need to solve for x, but you guys, this is actually way better than the first one because our x squareds if we subtract an x squared from both sides, they cancel. So that gets rid of that, and that gets rid of that. So now all I have to find is this x times the 32. So I'm going to subtract 256 from both sides so that I can isolate this x that's attached to the 32. So 1024 minus 256 is 768, which is equal to 32x. So if I divide by 32 on both sides, which is my last step, I get, and I'm going to write it over here, x is equal to 24. So that's how you're going to do B and D. So I'm not going to show the work because I have all the confidence in the world that you can do it, but I'll let you know that the answer for B is x is equal to 64, and the answer for D is x is equal to 16. So that's the answers that I got, and hopefully those are the answers you get. So when I come back, I'll check those two to make sure that they're in your notes and that you did them. So if you need to pause the video right now to finish those two problems, please feel free to do so. Okay, the next theorem that we want to know about tangent segments says that tangent segments from a common external point are congruent. So if we have more than one tangent segment that's touching the same circle and they're coming from the same point, then those two lines are congruent. So what we're saying is if the line segment SR, if that line segment from here to here and the line segment S to T, because those are my two tangent lines, right? So the line segment SR and ST, those two tangent segments, if those two are tangent segments, sorry, to circle P, then we're saying SR is congruent to ST. So that's going to be a helpful theorem when it comes to solving. And so let's jump into the second example, part A. So we want to find the unknown value, or x, in part A. And in all the examples, they're telling us that JK is a tangent to the circle L and that JM is a tangent to the circle L. And they're telling us that the tangent points are at K and M. So all they're trying to tell us is that this segment and this segment are congruent, just like how SR and ST were congruent in my top theorem example. So that means that we can just set these two things equal to each other. So we have 2x plus 2 is equal to 5x minus 4. And however you like to solve multi-step equations, I like to subtract the variable first and get that isolated. And then I'm going to add the other thing to the other side. So this cancels and this cancels. 2 plus 4 is 6. 5x minus 2x is 3x. If we divide both sides by 3, we should get an answer for x is equal to 2. Okay, so now let's do part B. So we know that KJ and MJ, because K is tangent to circle L and M is tangent to circle L, those two tangent segments are congruent. So that means 4x squared plus 5x is equal to 6. And when we have an x squared term and an x term, you know what we need to do. We need to factor. And when we factor, we want one side equal to 0. And we always want the a term or this term to stay positive, which means that I should subtract 6 from both sides to get this side to cancel the 0. So I should get 4x squared plus 5x minus 6 equal to 0. So remember back when we were in factoring in last year and when I reviewed last semester and this semester how to factor, when our first term or our term, the x squared term, if that number is not 1, we need to do the AC method, or if you want to do guess and check, just do guess and check. But those of us who liked AC method, this is a refresher for you. So we need to take a times c, right? A times c, which is 4 times a negative 6. This is my a term, b term, c term. So a times c is 4 times a negative 6, which is a negative 24. And my b term is 5x. So we need two factors of negative 24 that will add to a positive 5x. So we know that negative 24 has factors of 8 and 3. And in order to add to a positive 5, negative 3 has to be negative in order. So 8x times a negative 3x will give me negative 24x squared, and 8x plus negative 3x will give me a positive 5. So what these two numbers do then is they replace that 5x term. We're splitting this up into the two numbers that we just found. So we have 4x squared plus 8x minus 3x minus 6 is equal to 0. So now we factor by grouping. So we look at the first two terms. So within the first two terms, what's a GCF that we can take out? We know we can take out an x, and 4 and 8 have a GCF of 4. So we're going to divide out of both of these terms a 4x. 4x squared divided by 4x leaves me with x. 8x divided by 4x leaves me with a positive 2. Now we have to look at the last two terms, negative 3x and negative 6, and we need to take out a GCF out of these two. And we can take out a negative 3, which if I divide negative 3x by negative 3, that leaves me with x, and negative 6 divided by negative 3 leaves me with a positive 2. And so now we notice that the things inside the parentheses, x plus 2 and x plus 2 are the same, which is exactly what we wanted for factoring by grouping, because now in the whole term, this minus this, we can take out a GCF of x plus 2. So that means that I'm going to have x plus 2 in parentheses and 4x minus 3 in parentheses. And now when we have these two sets of parentheses set equal to 0, that means that I have to set each factor or each product equal to 0. So x plus 2 equal to 0 and 4x minus 3 equal to 0. Well, the one on the left is easy. It's a one-step equation. So in this case, x is equal to negative 2. And then on the right-hand side, we have to add 3. So it's a two-step equation. So we get 4x is equal to 3, divide by 4, divide by 4. That means that x, and I'm just going to leave it as a fraction, x is equal to 3/4. So for part B, those are my two answers. And we knew that we would have two solutions because we had an x squared term, meaning that we would have two solutions. So we have x is equal to negative 2 and x is equal to 3/4. So what I want you to do is I want you to do part C. So on the first flap, the radius flap, that theorem, I wanted you to do parts B and D. And now on this flap, the points of tangency, I want you to do part C. And the answer that you should get for part C, there should be two, because remember we're factoring, so there should be two solutions, is x is equal to 1 and x will be equal to a negative 5/2. Those are the two answers that I got, so when I come back tomorrow, we'll double check that you got those as well. So remember that our homework for tomorrow, on top of taking notes in this video, is that under the radius flap, I want you to do problems B and D, and I told you those answers, so if you didn't get those answers, you did something wrong. And then also on the last flap, the points of tangency, do the last problem, part C. And make sure you do all three of those problems because I will be checking notes when I come back. So thank you all for taking such great notes, and I shall see you soon.